So let's consider equilibrium of some hanging objects. Okay, so pretty straightforward. Let's imagine that we have an object right here and it has a weight of 25 pounds. Okay, so free body diagram, we know that mg is pulling down, tension's pulling up, it's hanging there, so it's an equilibrium, so that means that these two equal. Basically another way of stating this is force up equals force down, force left equals force right. Everything is straightforward, so that's going to be it. mg is 25 pounds, so the tension is 25 pounds. Very straightforward. Well, now let's say we have this object and we pull on it like this. And so now we're pulling like this with some tension T2. This is tension T1 holding it up here. And we're pulling it so that it's pulled over an angle of 20 degrees. And so I want to know now what are the tensions T1 and T2. We're going to still say that mg is going to be 25 pounds for this object here. Okay, so we look at it and we say, okay, free body diagram, we got T2, we got T1, okay, this will be an angle 20 degrees, and we got mg. So we look at it and we say, well, the force up has to equal the force down, and the force left has to equal the force right. That's what you mean. If you say that sum of the forces is 0, that means that these have to be met. It also means the force into the screen has to equal force out of the screen. Well, force up is going to be T cosine 20 degrees. Force down is mg. Well, that makes it really simple. So T is going to be mg over cosine 20 degrees. So that's 25 pounds over cosine 25 degrees. So T1 is 26.6 pounds. Okay, so force left equals force right. So force left is going to be T sine 20 degrees, or T1, or I guess we can call that T1. Okay, T1 sine 20 degrees, and then that has to equal T2. Well, we just found out what T1 is, so that's 26.6 pounds. Sine 20 degrees equals T2, so T2 is going to be 9.10 pounds. Okay, so there we have just pulling the thing off to the side. Okay, so let's say, again, we have an object right here. Okay, has some mass m. Let's say that the mass is going to be equal to 10 kilograms. Okay, now if this mass is hanging by a single rope or string or something like that, then we have tension up, we have mg down, so the tension equals mg, and so that means that the tension equals 10 kilograms times 9.81 meter per second squared, so the tension is 98.1 newtons. Again, nothing new and different here. We started this idea back in chapter 5. So what if we had two identical strings pulling up? Okay, let's say they're symmetric. We'll make them non-symmetric in a little bit, but let's say they're symmetric, and so if they're symmetric, then free body diagram, we have two tensions pulling up, we have mg pulling down, so 2t equals mg, so that means that tension equals mg over 2, so that would be 98.1 newtons divided by 2, so that's 49 newtons. Again, nothing new and different. This is exactly all the way back to how we introduced some of these tensions with when we were talking about this way back in chapter 5. Now, suppose we have pulling this way and pulling this way. So this is now going to be tension 1, and now it's not symmetric. So this is going to be an angle 12 degrees, And then this tension 2 is going to be 31 degrees from the horizontal. Okay, so free body diagram. Okay, we got T1 at 12 degrees, and this is going to be 31 degrees T2. We have mg. Okay, mg we know is 98.1 newtons. So force left equals force right, force up equals force down. Okay, so force up is going to be T1 cosine 12 degrees plus T2 sine 31 degrees. That's going to equal mg. Okay. Force left, T1 sine 12 degrees equals force right, T2 cosine 31 degrees. Now again, pay attention to where the angles are to determine whether you get sines or cosines. Okay, well, now what do? Because we cannot do what we did before, and that is just solve here and plug in. Well, yeah, we can, because now we can just say, oh, wait, we can solve here. We can say that T1 equals T2 cosine 31 degrees over sine 12 degrees. Okay, or we could have said that T2 equals T1 sine 12 degrees over cosine 31 degrees. It doesn't matter. You're just solving here and say, aha, I can now take that and plug in up here. Before, if we solve for T1, you could have plugged it in right there. So if we do that, solving here, then we have T1 cosine 12 degrees plus, now T2 we now say is T1 sine T1 sine 12 degrees over cosine 31 degrees times sine 31 degrees equals mg. So that's T1 cosine 12 degrees plus T1 sine 12 degrees tangent 31 degrees, because sine over cosine is tangent equals mg. So T1 equals mg divided by cosine 12 degrees plus sine 12 degrees tangent 31 degrees. mg, you remember, mg was 98.1 newtons. So if I plug all that in, then we get that T1 is 96 newtons. Okay, well, we already have a formula for T2. T2 was T1 sine 12 degrees over cosine 31 degrees. So we now know what T1 is. T1 is now 96 newtons. So if I plug in, I get 23.3 newtons for T2. Okay, so there we have several different examples of hanging objects and finding tensions.